So, what are you supposed to know about standard deviation? How are you supposed to be familiar with it? So, your concentration, first and foremost, should be on what standard deviation tells us about the data. Okay, the standard deviation measures how far away data is from the mean or the center part of the data, the mean, the median, the mode. So if the standard deviation is actually 0, that means that every score is exactly the same. But the higher the standard deviation, the more the scores spread away from 0. So if those scores, if you have a standard deviation of 2, as opposed to a standard deviation of 22, that means the standard deviation of 2, all the scores are about the same. 22, they would be pretty different. Going back to the example when I spoke of the houses in Tennessee, in the first case where everybody was in that gated community and all the houses more or less cost the same and everything was of the same value, the standard deviation would be a very small number. Compared to when we got out on the roads and we started to see these absolutely gorgeous homes that were probably close to $1 million, and then we would see these very rundown, kind of beat up homes with very little property value right next door on either side of them. So in that case, the standard deviation of home values would be very large. Okay? All right. So the next thing we want to do is give you an actual problem to do. So you can take these values and you can put them all into L1. You could do 33. Well, remember how to get to L1. It's stat, edit. Then you go to the top of the chart. And at the top of that chart, it'll say L1. You want to go all the way up to the top. When you get to L1, you hit clear enter. That'll wipe all the values out in the row. Then you go down one level and you start inputting values. And you'll go 33, enter, 42, enter, 49, enter, 49, enter, 53, enter, 55, enter, 55, enter, 61, enter, and so on. You could do that for all of these scores. In fact, I think that's the best way to enter these scores because it's not like there's 8 or 10 of the same score. So put them all into L1 and then you go to stat calc, one variable stats, and right away up will pop the sum of the x's, the sum of the x squareds, and then you'll get into SX, which is the sample standard deviation. There's also rho x, which is the population standard deviation. But we want to go with SX almost all the time unless told differently. And that will give you the answers to part B. The sample mean, sample standard deviation, the median, the first quartile, the third quartile, and the interquartile range. You won't see the median or the first and third quartiles or the interquartile range. That you have to figure out on your own. You won't see them right away displayed. You got to keep putting the arrow button down to find those once the sample mean comes up. Okay, as far as creating the chart goes, you have to do that regardless because that's what it's asking you to do. I'm not going to show you what that chart looks like, but we've done a number of them and we will continue to do more of them as time goes on. So let's start putting those values in the calculator, or do it from the chart and calculate it on your own. Okay, go ahead, do that with some stop and start, and I will show you the correct answers. Okay, so the sample mean works out to be 73.5. The sample standard deviation works out to be 17.9. So the sample mean, when you get to the graphing calculator and you do stat calc, it's going to be X bar. That's your sample mean. It'll tell you 73.5. Sample standard deviation is 17.9. And then if you keep scrolling down, it'll tell you Q1 equals 61, median equals 73, Q3 or third quartile equals 90, and then you need to know that the interquartile range is the third quartile minus the first quartile, which is 29. Okay, so the power of the graphing calculator is very real, and it does save you a lot of work when it comes to standard deviation. The question I have for you is, with a sample standard deviation of 17.9, do you think these scores are pretty much always the same, or do you think there's some spread in the scores? There's definitely some spread in the scores. All right, a standard deviation of about 2 or 3 or 4, that would mean there's not much spread. And then if you look at the scores, 33, 42, 49, all the way up through the 50s, the 60s, the 70s, the 80s, and the 90s, even to 100, suggests that these scores are spread out pretty far. And The standard deviation of 17.9 reflects that. So now we're going to do a sample standard deviation without or with intervals, okay? And we've done some work with intervals before, and it's pretty much the same exact thing. It says it in red here, and it's very important. You have to calculate the midpoint of each interval. So for the first one, the class that says 0 to 2, the midpoint is 1. For 3 to 5, the midpoint is 4. For 6 to 8, the midpoint is 7. So that would mean that there's, for interval purposes, remember, you do not get an exact standard deviation, you get an approximation of it. There's 1 1, there are 6 4s, there's 10 7s, there's 7 10s, there are no 13s, and there are 2 16s. Now, I'm going to not do this alone. I'm not asking you to do this alone, but rather to do this with you, okay? Now, the only difference between a standard deviation and the standard deviation with intervals is that now you're going to use a frequency. And the way you calculate it with intervals is to use L1 and L2. So we go to Stat Edit, and we're going to fill in values for L1 and L2. L1 will be the midpoint of each interval, 1, 4, 7, 10, 13, 16. And L2 will be the frequency of each interval. So L1 and L2 just match the order of the columns in the table that were drawn up. And that will go 1, 6, 10, 7, 0, 2. And then, just like before, you go to one variable stats, because it really is only one variable. The frequency is not a second variable. The frequency is how many of the only variables, which is the first one. So I hit one variable stats, and when I do that, I get this. That x bar, 7.5769, blah, 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 the sum of the x's, the sum of the x squareds, and so on and so forth. That tells you the standard deviation is about 3.5. And if you want the first quartile and everything else, you see this down arrow here? Well, first, next to the down arrow, it says n equals 26, which means there were 26 scores. So what I always like to do is count the scores that they give me in the problem and make sure it's the same number as n here. That means more than likely I entered, more than likely I entered everything correctly. And then if I just keep pressing that down arrow, the next thing that will come up will be the first quartile, the median, and the first quartile, median, third quartile, maximum, minimum, and so on. Okay, here's a couple of quick questions to answer. Why don't we do some stop and start here? Okay, you can use your calculator or you can use a table for the first one. That's going to take you a little bit if you use a table. And then also number 2. And then you do stop and start, and I'll go over it. You can see how they recommend 120 seconds for the first one. They're assuming you're using a calculator. Okay, so I did this last night, and I didn't write the answers down now, but I remember doing it last night. The correct answer to the first one, I'm 99% sure, worked out to be 7.26. So just to remind you of how to do it, stack edit, clear out L1 and L2 if there's any values in L2, and then enter into L1 all of these values, 5, 10, 7, 12, 0, 20, 15, 22, 8, and 2. And then you go to stat calc, one variable stats, and then enter, and in front of you will pop the standard deviation. If they don't say which standard deviation, you always assume it's the sample standard deviation. Okay. Question number 2. If a number is added to a set that is far away from the mean, how does this affect the standard deviation? It's going to increase the standard deviation because it's far away from the mean. That assumes that it's farther than other scores when it says far away. Okay. We'll come up with a couple more questions for you to do in a fourth video.